Lesson 73, formulas for sequences. So here's an example. If we're asked to find the 8th and 11th terms, and we're going to give two different examples. So a sub n equals 3 times n, and a sub n equals 2n plus 1. So to find the 8th term, so for the 8th term, n equals 8. So we're going to have a sub 8 equals 3 times 8, or 24. For the 11th term, n equals 11. So a sub 11, that just means the 11th term is 3 times 11, or 33. In this term, the 8th term, a sub 8 equals 2 times 8 plus 1. We're just plugging in 8 for n. So 16 plus 1 is 17, and then a sub 11 is 2 times 11 plus 1, which is 23. Here's another example. We're given this formula, a sub n equals 2 to the n. Give the first 5 terms. So we can make a box for our term number. That's going to be n, and then the value of that term, which is a sub n. Okay, so we're going to come across, we need 5 terms. So that just means that n equals 1, 2, 3, 4, 5. So a sub 1 is 2 to the first power, which is 2. 2 to the second power is 4. A sub 3 is 2 to the third power. And then we have to the fourth power, and then to the fifth power. So the first 5 are 2, 4, 8, 16, 32. And we would just list it out just like that. That's the first 5 terms. Now we're going to go over something really quick called triangular numbers. So triangular numbers are, it's basically how many dots does it take to make a triangle. So they're counting 1 dot as a triangle. Then we have 3. Then if we add another row, we have 6. And then another row, it's going to be 10. And we can keep going like that. So this is actually a sequence. And the formula for these triangular numbers is a sub n equals n times n plus 1 divided by 2. So let's say I wanted the 5th term. Here we have 4. We want the 5th term. We can plug in 5 for n. We get a sub 5 equals n, which is 5, times 5 plus 1 divided by 2. And that's just equal to 30 divided by 2, or 15. Those are triangular numbers. So 1, 3, 6, 10, 15. Then we would have to add 6 more to get 21. Or we could plug it into our formula. Super awesome. Okay, end of the lesson.